Great. Good morning or afternoon, everyone. Welcome to the first invitation-only Flex live demo. I'm Jesse Kriege. I'm a senior product manager here at Opentrons, joined by Anthony Willey, who you'll see in a moment. He's also a senior PM here. We're going to give you an overview of the Opentrons Flex. We're going to run through a short demo and then answer any questions you may have. I see a lot of people are still filling in, so that's super great. We're filming this from our demo lab in New York City. If you're in the area and would like to see the robot up close and personal, please get in contact with your territory rep, and they can help set that up for you. Come and visit, it's great. You can, of course, catch us and the robot at several conferences and regional events as well. We'd like to remind everyone that this demo is being recorded and it will be available on our website afterwards. We'll also be sending a copy of the recording via email within 48 hours to everyone attending this event. To help with the experience, everyone is on mute. To ask a question, please use the Q&A box on your screen, and we'll answer questions at a few key points in this talk. So let's get started. With that, here's Anthony.
Cool. Hello, everyone. My name is Anthony Willey. I'm a senior product manager here at Opentrons, and today I'm going to be walking you through a very basic workflow from creating a protocol to running it using the Opentrons Flex and the supporting software ecosystem around it. So to get started, of course, we need a protocol, and we'll be spending some time today to build one. But before we do that, I just wanted to highlight a few of the different ways that you can go about creating or obtaining a protocol for use on the Flex. So the first one that I'd like to highlight is the protocol library. If you're not familiar with the protocol library is a community-generated and community-centered repository of featured and Opentrons verified protocols. You can use the protocol library to browse many protocols across a very wide variety of applications. And download them to run right on the robot, or make further modifications to specific parameters or equipment specific to your equipment and to your experiment needs. When these files are downloaded, they're downloaded as Python files, so they can be run right away or brought into our Python API for further edits and modification. You can also build protocols from scratch using the Python API, which we have designed to be accessible to anyone with basic Python and wet lab skills. And if you are not familiar with Python, if you're not really feeling too skilled there, we do have a lot of really great documentation on our website that can really get you started writing protocols in Python and really leveraging its full power for advanced automation. The final self-service way to create protocols is with the protocol designer, which is a graphical interface that allows you to write scientific protocols without having to write any code. And that's what we'll be using to build the protocol today. I will point out we have some other very interesting, fun things cooking. And so if you're especially interested in some no-code ways to create protocols, definitely recommend you check out our ChatGPT webinar next week. And also, if self-service isn't your thing, we do offer custom protocol development services as well. So if that's a path that you're interested in, you can definitely get in touch with us. But for today's session, I wanted to walk through building a elution protocol in Protocol Designer. So I'm going to share my screen. And hope everybody can see. So what you're looking at here is the homepage for Protocol Designer. What we'll go through today, I just want to point out, will be a bit different than what is live, just because this is a pre-release version of Protocol Designer. You can expect an experience that looks like this when the Flex starts shipping in August. So to start, we're gonna click Create New. And you can see here, we have two different pathways that we can take. We can create a protocol for our OT2 or our newly introduced Opentrons Flex. So I'm going to choose Opentrons Flex and hit Next. And here, if you are familiar with Protocol Designer, we've introduced a new getting started, create a protocol flow, which hopefully improves on the overall UX when creating a protocol. Definitely interested to hear what you guys think once you can get your hands on it. So, but for now, let's since we're building an elution protocol, I am going to just put in elution example. I'll give it protocol name. Here we have a place where we can give some more description and an author, which I'll put my name here. And wanted to choose this protocol because it is a pretty common process, especially at the end of an extraction or a series of wash steps. So we have on the Flex 4 pipettes that will be available in August: the 1-channel 50, the 8-channel 50 microliter, and the single and 8-channel 1000 microliters. Nice thing about these pipettes is they have much wider ranges than the OT2 counterpart. So 1 to 50 microliters for the 50 and 5 to 1000 for the 1000 microliter. I'm going to choose a couple of pipettes that I know I already have set up on my robot. So I have a Flex 1-channel 1000 microliter. I'm going to click next. And I'm also going to add a 1000 microliter tip rack. And I'm also going to add a Flex 8-channel 50 microliter pipette. And I will put a 50 microliter tip rack on the deck as well. So here I can choose some additional items. This is where you would add modules, and we have a few new additions that are coming alongside Flex. So the magnetic block is something that I'd be looking to use in this protocol. I already have a thermocycler on the deck. I don't need it, but just to make sure that my deck is looking accurate, I'm going to add that. I have a heater shaker that I'll need, and also very exciting new feature for the Flex, the gripper. So I'll add a gripper to my protocol as well. And we'll move on to the file details. So here's just, I can review everything that I just input into that series of modals. And I can make a couple of changes here if I wanted to swap the pipettes from left to right. If I wanted to move any of the modules around on the deck, I can do that from this page. So I'll just say move the heater shaker over to slot C3. And the rest of the stuff looks good for now. So my next step will be to continue to liquids. And here I will add, because this is an elution, I'm just going to pretend that we have our samples and our beads together in a well. You can give a color, give a description. So I'll change that color to yellow, samples and beads. And then I'm also going to add an elution buffer. And I don't know, let's make this blue. Cool, so we have our liquids, and now we're ready to move on to the design tab. Here we get a little helpful blurb about setting up your protocol. So if you're new to protocol designer, you can get some more information to help get you started. So here we have our starting deck state as I've specified thus far. I'm going to need a few additional things. So I just want to point out some of the stuff you can do with this. Is very easy, intuitive. So I've got my 50 microliter tip rack over here. Say I wanted to move it around. Say I want to move my 1000 microliter tip rack up here. I can do so. Just if I wanted to add labware to any of these modules, I can just hover over the module and click add labware. If I wanted to move a module to a different spot, I can come back to the file tab. So let's just, I don't know, for sake of example, move our magnetic block over to slot D3. And we can get back to our design tab and we can see that's moved. Cool. So what will we need for this protocol? Well, first thing, I am going to add a sample plate directly to my heater shaker. I want this to start right on the heater shaker. So I'm going to call this samples and beads, and I'm going to click add liquids. I'll choose the columns that I want to add liquids to. I will select my liquid, samples and beads, and put in a volume. For this, I don't know, about 35 microliters. Next, I will add a reservoir for my elution buffer. So I can do that by clicking add labware. And you can see all of the different types of labware that I'd be able to add to the deck. For the purposes here, I would add say a 12 trough. We'll call this elution buffer. I'll add liquids, and I'll choose my columns where I'm adding. I'll pick a volume. Great. Now I have one more piece of labware to add, which is my destination plate. So for this, I will choose a 96, a nest. I'll call this destination, and I don't need to add liquids. So I will leave this empty. Awesome. So our deck is set up and ready to go. We can start getting into the design. So because I know the first thing that I'm going to want to do is bring some of that buffer into my sample plate, I'm going to add a heater shaker step, which I can do by clicking add step and scrolling through until I find the heater shaker step. You can see the magnet and temperature are disabled because I don't have either of those modules in this protocol. So I'll add a heater shaker step, and I just want to make sure that the latch is closed before I do any interacting. And you can see there's a number of other controls that you have here. I don't need any of these yet, but we'll come back to this later. For right now, I just want to make sure that that latch is closed. And now I can transfer some elution buffer. And here is our transfer form. You can choose which pipette you would want to transfer with. I'm going to use the 8-channel 50. And I am going to transfer, say, 10 microliters. And I'm going to transfer it from our buffer plate, specifically this trough. And I'm going to bring that into our sample plate on the heater shaker. And I'll select the wells that I'd like to transfer to, save my selection. If I did want to add any kind of advanced pipette settings, I can do that by opening up this gear icon over here. And you can see there's a number of other pipette settings, pre-wet and touch tip, air gap, delay, a number of things. I don't need any of that for this protocol, so I'll leave it alone, but there's a lot of good functionality under there. Cool, so we'll save this step. And then the next thing I'm going to want to do is shake the sample plate on the heater shaker. I'm going to just intentionally put in an RPM that the heater shaker is out of range, just to show you. I think one of the nice things about Protocol Designer is that it's outfitted with a lot of really good errors and warnings, and effectively like a guardrail system that can allow you to have confidence when you're creating a protocol that whatever you export from Protocol Designer will be viable and will run successfully on a robot. So 100 is out of range. I'll change that to 200, and I will set a timer for 30 seconds. Great. Now my next step, I know I'm going to want to move my plate to the magnetic block, so I'm going to add one more heater shaker step. I am going to click latch open, and then I'm going to save. So now I can use a exciting new step that we've added to Protocol Designer that works both for OT2 and for Flex, and which is the move labware step. So effectively, this allows you to move labware around the deck during a protocol, either manually with a pause or in an automated fashion using the gripper, which of course is a Flex exclusive feature. So I'm going to use the gripper to move my heater shaker or the sample plate that's on my heater shaker to the magnetic block. And so here we see my labware that I'm moving in the new location. I'll hit save. And then finally, I'm going to actually, before I do that, I would like to add a pause step and leave it on the magnetic block for a period of time. So here's a pause step. So you have a few options. You can pause until you tell the robot to resume. You can pause until a certain temperature is reached, or you can delay for a certain amount of time. I think we'll only need 30 seconds or so to get those pellets down so we can get the target liquid that we want. So let's put in one more transfer step. I'm going to transfer all of the liquid in these wells, and I'm going to take this from our sample plate from these columns, and you can see the makeup of the liquid in those columns at this time. And I'm going to move this to my destination plate, and I will also pick these first two columns. Save that step, And there we have a very basic elution. If I wanted to review, you can kind of scrub through the protocol timeline here. So we have heater shaker. This is when the latch is closed. We're just making sure that it's closed. We transfer liquid to the sample plate. We shake for 30 seconds. We open the latch. We grab that labware. We move it to the mag block, and you can see that moving as we go through the timeline. And then finally, we transfer to our destination plate. So now we're ready to export this file and bring it into the app and onto the robot to run. So in order to do that, I just go back to the File tab. I click Export. It might give you some information. For example, here, I'm not actually using the 1001 channel on this protocol, nor am I using the thermocycler. So it's just saying like, hey, make sure those things are on. They're going to have to be on if you're going to run this protocol successfully. But it's cool. I can still export. So I continue to export. And over here, I have my my protocol. So great. Now what do we do with this protocol? Well, I will bring up a pretty early version of the Opentrons app. And this is where we can actually take that protocol and get it ready to run. So simply by clicking import a protocol, I can browse files on my computer, or I can just drag and drop. So we bring the protocol in, and I already have this protocol set up here. So here we have, actually, before I move on, I just want to pause in case there are any questions.
We do have a couple of questions. One I'm going to save to the end, but one from Path I'm going to ask now because it's related to what you just showed, Anthony. So is there a way to pause and provide user input with a button selection or text box? I presume that's kind of halfway through the protocol run is what, but Path, if you have any additional information, keep typing.
Yeah, so we do have a message box on a pause step. So I can't say if I'm familiar or not if that actually shows up during a run while you're on the run, but you can put in the protocol, I can show you what that looks like. During the protocol design phase, let's go back here. So say like, I wanted to also add a message, maybe like you're sharing this protocol with a colleague or something before it runs. You can be like, this pause is for magnetic step, right? Whatever it is. Then you can save, and that message is actually, attached to that pause step in the protocol designer.
Great, thanks, Anthony. We are having more questions, but I think we can leave those till the end.
Cool. So I'm just going to really quickly show you what this protocol looks like in the app before I pass it back off to Jesse to show you the touch screen. So here's our protocol that we just built. You see our metadata up on top. And this is a really nice way to just kind of make sure that, if you're getting ready to run a protocol, that you have all of your materials, your labware, your liquids and whatnot. We have a really nice deck view right here. We have our robot configuration, which shows us the pipettes that are used in the protocol. It shows us the modules that are used in the protocol. We also have our labware tab, which shows us all of the labware used in the protocol and in what quantities. You can also dive deeper into the labware definitions from here, if you so desire. And then finally, we have our liquids tab, which shows us the liquids used in our protocol, as well as the volumes. Cool. So at this point, I have two choices. I can either proceed to get set up to run and then run the protocol from the desktop app, or I could use this exciting new feature, which sends it right to the Flex, which you can then pick up using our new touchscreen. And for that, I will hand it back off to Jesse.
Awesome. You're going to hear me. I'm going to have another camera that's zoomed in on the touch screen of the device. So the protocol that we just received. And then, awesome. One of our kind of product theses in designing the Opentrons Flex was to make sure that users could use this device in a shared setting in a lab where multiple people might be running things on it. And a big part of that is being able to run things without a computer. So we have the touchscreen of the Flex. This is the protocol that we just sent. We can select it. And we'll be given, scientists generally tend to like checklists. We'll be given a checklist of all the things that we need to do. We can run in, we can look at the instruments that we have. We can calibrate our instruments. We can view modules. I can see here that I'm missing a heater shaker from the deck. That's because my heater shaker is not on. So I can turn my heater shaker on. I can go through. I see that my modules are now connected. I can look at my labware. I can look at labware position check. And I can also look at liquids as well. So a lot of opportunities to kind of check your work, make sure that your protocol is going to be successful before you actually go into the phase of running it. From there, I can start my protocol. And what's really nice is as the machine runs, we'll be able to see a live view of the steps that the machine is executing, which is, again, really helpful for visibility, also for logging, and just kind of getting a sense that the machine that you're using is performing as expected. Great.
Cool. So that is a very brief, quick overview of the Flex software. You can see it's pretty quick and easy to get a protocol up and running. I guess now would be a good time for questions.
Okay, so we have quite a few questions. I'll just start at the top and go on down. So the first one is from Zhang Xiao. Can this new Opentrons change or top up tip boxes while running?
Yeah, that's a great question. For high throughput applications, obviously, that's a feature that we would like to support. Part of our intention with the gripper and adding more opportunities to move things around on the deck is to increase throughput. Obviously, tip supply is a big part of that. We are building out support for staging areas that will allow more tip racks to be placed. At this time, the machine is not able to refill tip racks itself, although that is a feature that we are looking into.
Maybe Jesse, you could just point out where those additional tip racks would go, just as well see the deck.
If you can see our deck view here of the machine, we have tip racks here loaded onto our device. Over here on this side, we have part of the reason that the gripper is on the extreme right-hand side of the gantry. There's a whole area over here that the gripper can reach that can't be accessed by pipettes. And this area gives us 4 more staging slots where we can add tip racks or whatever it is that we need to move into the deck to perform higher and higher throughput protocols.
Great, thank you. Perfect. Okay, so next question from Stephen. Are there liquid classes?
Yeah, so liquid classes is a roadmapped feature in our software. Obviously, our priority right now is getting the Flex wrapped up and out the door. Liquid classes we plan to have as a fast follow feature that will be supported. It will come via a software update. What's really nice about the Flex is you can update it again without plugging a computer into it. So support for this will come over the air, and it should be in your hands soon after you get a Flex, should you choose to buy one.
Perfect. So next question from Abraham. Will there be any substantial changes to the Python API?
Yeah, that's another great question. Actually, no, and that was a very intentional choice. We wanted to make all of the commands, all of the names as semantically reasonable as possible. We wanted to make it so humans could look at old protocols and old Python scripts and just adapt them to the new device if you've already been using an OT2. So the function of the API is largely the same. There are some conventions for naming and calling new devices, but this is all in our GitHub documentation online. So you can actually train up on that before you get a Flex. That's available now.
Perfect. Okay, this one from Anonymous. Is there a report provided at the end of the experiment that shows all the actions, volumes transferred to each well and any errors that occurred during the run?
Yeah, so we do have logs of every robot action down to stepper motor commands at the firmware level. So there's a lot of granularity you can pull out of the user logs if you download them. You're also able to, we have a much more robust system of errors that we are implementing in stages. Initially, errors will give you error messages and error codes that you can go and look up. As we build out more and more of our sort of error product, we hope to provide 21 CFR Part 11 compliance with logging, access control, and sort of uneditable logs that are more human readable for the purposes of an audit than the logs you can currently download, which have all that information, but are just a little bit more work to parse through. So that will be improved soon.
Great. This one from Barath, I hope I'm pronouncing that correctly. Can we use the gripper just to move the lid of a 96 well plate?
I'm not sure if I entirely understand the question. The gripper can move a 96 well plate into the thermocycler and into any of our other modules. As for a lid, I don't know what that's referring to.
Zach, have you tested that? So Zach is should be on the line as well, and has done a lot of testing in the lab.
So yeah, we have not started the testing for any lid movements. I'm not positive if that's going to be a fast follow feature or if that's going to take a little more time. Developing all of the gripper actions and testing just to make sure that all of the labware that we're using is going to go well. That took up a lot of our time, and that's kind of what we're focusing on, just to make sure that at launch all of the plates are actually moving the way we want. I think the lid will follow, but it will not be at launch.
Okay. Thank you, Zach. Okay, second one from Path. This is a long one, so pay attention.
I can answer this question. I hope everyone attending, please, if you have a chance to read it. Essentially, it's asking, there are pop-ups in the run log. Yes, we do have a much better system of user intervention models now. These will pop up both on the desktop app and on the on-device display, the screen that you saw me demo earlier, which is great. And then in terms of adding input, like number of reps to run for a particular type of protocol, those are some more fleet management style commands that we're building in as fast follow features.
Okay, so question from Anonymous, which I think I will answer. Is a remote custom protocol development included when purchasing the Flex NGS workstation? So the answer to that is yes.
Great.
Simply. So yes. Okay, next one from Hunter. The protocol designer for the Flex showed the trash in the same place as the OT2, but I was informed that the trash chute would come out of the front of the Flex. Can you speak to this difference?
Yeah, so the trash chute is something that's currently in development. I actually saw one yesterday. It's a beautiful piece of hardware. It mounts on to the front of the robot right here. Essentially, it's a L-shaped chute. It protrudes forward and allows you to dump consumables out of the front of the robot into either a trash can or a trash bag.
Yeah, and so, but you can use either, I think, Hunter, just in case. So, you can use the regular trash bin at the back, which is a closed device, so limited capacity, or the chute, which ejects into, a bin the size that you want it to be.
Both the trash chute and the trash bin in the rear, the waste bin in the rear of the robot, are configurable on the deck, so you can move them around as you wish.
Great. So this is from Shumei. Can we see the instrument in action? So we did just show that a little bit. I think we could run it again while we're going through, because we still have quite a few questions to go through. Maybe we could just run it again, and I don't know if Jesse or Anthony, if you want to speak to kind of what's happening at each step. It's a pretty short protocol, so it should only take 5 minutes.
Yeah, I think if folks want to watch the robot move around while we move through the rest of the questions, it's probably a good use of time. Right now, we're just doing setup for run again. We're confirming all of our checklist items here, and we're starting our run. So the machine's going to move around and do stuff. I'm going to keep answering questions. Steve, Stephen Bates, is barcoding coming down the road. That is, accessioning is obviously a huge part of doing any kind of high throughput biology work. That is something that we are building into the Flex. This is not going to be a launch feature, but the ability to accession and handle samples is something that we have on our roadmap and plan to support in the future.
Great. So this one from Shang Chao. On the OT2, one big headache is that dropping tips is followed by a blowout automatically, which always causes aerosols. Is this improved in the Flex?
I think that actually might be a great question for Zach.
So I haven't heard anyone speaking specifically to this prop point. The nozzles of the pipettes are a similar configuration. I don't believe that's any software or firmware level configuration that we have. So I believe it's a very similar process in terms of dropping the tips. But I haven't heard that exact complaint or comment before. So I haven't really heard anything about the change for the Flex.
Okay, let me make a note, Shang Shao, and I'll see if they're I'll put it to our internal FAS team and see if they have any comment on that.
Great. Great. Awesome. As for the friend, if you don't mind, I'm going to just keep running down these if that works
Sure.
for you. Cool. Yeah, Andreas, your question, how is the computer where you wrote the protocol connected to the robot to receive the protocol? That's a great question. A big thing in designing the Flex has been connectivity. Obviously, we want these instruments to be as easy to use as an appliance, ideally. The way that we thought about the Flex is giving people multiple options. Depending on the security situation in your lab, there might be some hard requirements on not connecting to the internet. In the case of the demo that you saw, we sent the protocol from the run app that was on this laptop to the Flex to be run via Wi-Fi. So you can send protocols via Wi-Fi, you can send protocols via a dedicated USB connection, which is greatly improved from the OT2. And you can also send via Ethernet cable. So there are a lot of options for sending protocols over and generally communicating with the device. Great. As for what is the difference between the on-site scripting and custom protocol development, that might be a good question for Fran.
Yeah, so essentially it's just where the scripting is done. So on-site scripting is our FAS team coming on site, working in your lab with you to script and test your protocol. And then custom protocol development is the same activity, but done remotely. So you know, via email and a few calls, they would write the script and go back and forth with you to verify that it worked. So and there's obviously a price difference associated with that custom protocol development being a little bit cheaper, obviously.
Great. Awesome. Does the gripper work with semi-skirted plates? So we have a labware library and we work to bring labware into our ecosystem that we have verified with our internal science team as being performant. Semi-skirted plates is something we're investigating, but we don't have any current dedicated plates like this that are confirmed to work with the gripper. Obviously, you can create custom labware definitions. That's part of our system, is being open to new things. But that would be your responsibility to do.
Yeah, maybe just to add that we do recommend hard shell or Opentrons tough plates, which have a stronger frame. And we do recommend full skirted plates just because normal PCR plates kind of tend to warp. And that is also the risk with semi-skirted plates as well.
Awesome. Cool. As far as, is there a barcode reader? I addressed that earlier. Accessioning is a really, really key part of doing high throughput biology. This is something we're looking into. We have a couple of different options, more updates to come in coming months.
Cool, I can grab this next one. So do we have any tip on or tip type verification? Yes, so one of the very exciting things about the new pipettes on the Flex is that they do have a number of new sensors that will allow us to do all sorts of things. To this example, we have an optical sensor that will be able to determine if a tip was properly attached or ejected. So yes, we do have a tip on, tip off verification.
Awesome. Cool. As for the next question, is there LIS connectivity? So two-part answer. Part one, no, not at launch. Part two, we have a lot of internal applications where we do port data out of these machines. We have built out a working but not currently public API connection to Benchling to provide the robot logs, which can be ingested for performance analytics into their machine learning platform. So there is some LIS connectivity, but in terms of actual, coded accessioning sample management, that is a feature set that we are building out and hope to support on the Flex as it rolls out into the market over the last half of this year. As for the next question, I actually can demo that on the screen. So if we go back to the protocol.
Jesse, maybe just read the question because I don't think that everyone else can read it.
Okay, interesting. Great. So the question is there a load check for the labware, whether it is present or not, and also whether it is the correct one as specified within the protocol? So there is a check step for labware. As you can see on the on-device display, we can look at a map view of all of our different pieces of labware, and we can confirm if the labware in slot 2 is indeed an Armadillo 96 well plate with a full skirt. We can check all of our different items this way. This is a good checklist. You can view this in a map view. You can also view this in a list view, which I think is really helpful because you can run down your slots and complete them this way. So hopefully that answers your question. Parth, again, will there be individual pipette nozzle control for a multi-channel pipette, or will all the nozzles be controlled together for a multi-channel? I actually was speaking with someone a day or two ago who's working in cell culturing, and she had requested this feature as well. This isn't something we currently support with our pipettes, but it is something we're looking into and hope to support on the Flex in the future. Next question, what are the new features of Flex versus OT2? I could talk for like 45 minutes about what that is. I think at a high level, the three most important features are automated calibration. Calibration is now done with a capacitive sensor using a probe. It's pretty much entirely hands-off. That's a huge time saver and greatly increases accuracy. The second feature that I think is really, really cool and really important is obviously the addition of the gripper. Increases your walkaway time for NGS library prep, for example, significantly, which is really great. And then I think the third one is kind of a longer term horizon, but really important as well, which is extensibility. The system and the Python API and the controls of this device are open source, and we have designed this robot to work with more and more things, labware, modules, instruments. And there's a lot of really, really interesting opportunities that we're pursuing in terms of what you can do with one of these things, what kind of science you can do, and what kind of instruments you can bring onto the deck. Great. As for the next question, can we do liquid level sensing in Flex? I think that's a great question for Anthony.
Sure. So can we do liquid level sensing in Flex? At launch, this is not a feature or a capability that we will have enabled, but the good news is, yes, the short answer is yes, the hardware is outfitted for it. And this is something that we have prioritized on our roadmap. So you'll be seeing more on this in the future. And I can take the next one. Can you program loops or variables in Protocol Designer? At the moment, no, that is a Python only thing, but we are also putting a lot of work and thought into the future of Protocol Designer and looking at ways to make it easier to use. And we definitely see feedback coming on loops and variables, and so that's definitely something that we're looking into for the future.
Great. Awesome. As far as, can you elaborate a little more on how the Flex automatically calibrates? I'm not going to actually run through the calibration workflow here, but I will show you just a little bit on the deck itself of how this is done. As you can see, each deck slot has a steel plate in the center of it. There's a hole cut in this plate, and the pipette uses a probe, which is attached to the inside of the machine's case with this nice little magnet. You run the automated calibration flow. It's a guided wizard on the touch screen. The pipette will move to the center of one of these plates and using its capacitive sensor, essentially find the edges of it. We then do a binary search and we teach the robot geometry on its own, which is pretty cool. So again, calibration totally automated. You choose to start it you pick an instrument, you can do it with the gripper and the pipettes, and it will just go. Is it possible to run the calibration protocol through Python? Yes, with the asterisk that that's not a feature we are heavily testing or planning to offer as a, stated out of the box thing that's functioning. But yes, you can call calibration through Python. The behavior of the on-device display when you do that, again, may vary slightly, but that is a feature that you can do.
Okay, that is all of the questions so far. I'm just going to leave it open for 10 more seconds, just in case someone had something burning that they wanted to ask that they didn't get the chance to type out yet. In the meantime, is there anything else, Anthony, Jesse, you wanted to say? Oh, we've got one more question. Oh, two more questions. Okay. So we'll keep going. We'll keep rolling. We've got plenty of time. So take it away, guys.
Great. So yeah, Parth, with the integration of benchling in the future, would there be possibility to potentially run a protocol from benchling remotely? All I'll say on that is there's no reason you couldn't execute one of these scripts. That's entirely contingent on our integration with their robot control API being supportive. But in the scoping that I've done, our Python control set is generally compatible with their schema, so we should be fine. And then Jacob, will the Flex be able to count tips between protocols? At this time, yeah, we don't have software support for that, but that's a great call out and definitely something that we've looked into. Lifetime inventory consumption as well being sort of a logging product that we're interested in building so that folks can have a good sense of what their lab's consuming, what their throughput looks like, and also probably a better estimate of cost as well.
Okay, and now I think we might have come to the end of the questions. Is there anything else you'd like to say, guys, before we close the call?
There's a lot of really exciting stuff coming on the Flex. We've been really lucky to get to work on it. We think it's a really cool thing. We hope that you'll enjoy it also. It also looks like there's one final question that made it through.
Is there a possibility? So the question is there a possibility to use the 96 pipette head as a positive pressure module, i.e. to push liquids for SPE protocols? That I am not sure.
Yeah, at this time, we haven't seen anyone use one like that, and we don't plan to support that at launch. But if there is sufficient user requests from you all to support something like this, it's absolutely something we can look into. Great.
Awesome.
Thank you
Great
so much.
questions. Thanks so much, everyone.
Thanks, everyone.